So today what we're going to do is step by step derive the equation for a circle. What you see here, right here, is what they call the equation for a circle, and it looks kind of complicated, but I'm going to give you a tip, which is that doesn't it look an awful lot like a squared plus b squared equals c squared? And I'm wondering if that reminds you of anything. I'm hoping it does, because the Pythagorean theorem for a right triangle is a squared, which is a can be either of the legs, a squared plus b squared equals c, the hypotenuse, squared. Remember, that's only for a right triangle. That's what the symbol says. It's a right triangle. So if you look at these two, you can kind of see that they're similar. It's something squared plus something squared equals something squared. So the task we have today, that we were given today, is this. The project is derive this formula for a circle using this Pythagorean theorem. So where we're going to start is we're going to put a circle onto a grid, a coordinate grid, just like you normally see. And we're not going to assume that this center part is 0, 0. It would make it a lot easier if we did, but we're not going to this time. So we're just going to say we don't know what this circle center point is, and this is just the general form for circle that we're going to use. Then we're going to draw a line from the center of the circle to any point on the outside of the circle. It doesn't matter what point, just any point on the circumference of the circle. A straight line. Now we're going to name a couple of things. We're going to name the point at the very center of the circle, HK, and we're going to name the point that we chose randomly on the circumference of the circle, XY. So as you see, the name for this point here, the random point on the circumference, is XY, and this point here, the center, is HK. Now don't get worried. That sounds complicated, right? But these are just letters we're randomly assigning to 2 points, all right? So if we were going to then drop a line directly down and make a right angle, we would have a right triangle here. Now we know what this point is, HK, right? We named it HK, and we named this point XY. Now before we name this mystery point here, I want you to notice that we can use the Pythagorean theorem to find the radius here. We can say a squared, this a, plus b squared, this b, equals r squared, this r. And that's how we get this down here, right? So we're getting warmer towards the general equation of a circle. Okay, now be patient with me, okay? We have to name this mystery point down here. How do we do that? Well, let's start with its x-coordinate. The x-coordinate, because it's directly down from this point that we know is xy, if it's directly down, that x-coordinate is going to also be x. It's going to have the same x-coordinate. It's exactly as far out in the x direction as the one above it. So x starts with x. Now what about the y? It's exactly, y is the up and down coordinate. It's exactly as far up and down as the center is. So its y coordinate is k. So this mystery point that is in the middle of kind of nowhere, wherever we drew it, is xk. Now, if we had to derive a formula for a squared plus b squared equals r squared, we could now find the distance of a and the distance of b. So let's start with a. A is a vertical line, so we're looking for the distance between the second coordinate y and the second coordinate k, and the distance would be, as we see down here, y minus k, right? Y minus k would be this a distance. What about b? B is the horizontal distance, so it's the first coordinate. So it's the difference between x, which is this horizontal coordinate, and h, which is this horizontal coordinate. So we end up getting something that looks down like this. X minus h squared plus y minus k squared equals r squared. Oops, I didn't square the r down here. I'll have to fix that. But if we switch that around, make this r squared in your mind, if we switch that around, we now have the equation for a circle. So really it's just a Pythagorean theorem thing. We make this triangle, and we take some care in naming this line we made, find the distance for A, find the distance for B, and we've got it.